Systems of linear equations in two variables, part 2. We're looking at solving a system of equations. A system of equations is one or more equations of the same variable, like x and y. Linear, looking at the power of x and the power of y, we have a 1. This is a linear systems of equations. How we know so far to solve a linear system is by substitution. Solve for one variable, plug into the other. Elimination, make the variables have the same coefficient, one negative, one positive, so that when we add the two equations together, a variable is eliminated. And then we have a graphical method. For the graphical method, we, in order to use our graphing calculator, have to solve for y and then plug y into our calculator to get a graph. If they intersect, we have one solution. No intersection, no solution. If we graph and one equation is really the same as the other equation, they're on top of one another, then we have infinite solutions. Okay, we did problem number 18 last time. Let's work on problem number 20. For problem number 20, again, we're using the graphical method. So we'll start out with 12x plus 15y equals negative 18. We're going to solve for y so we can get this put into our calculator. So we have negative 12x minus 18. We're going to divide both sides by 15. And I'm not going to simplify my equation. I'm just going to go ahead and let the calculator do the work. I'm going to put this in y1 just as is. And let's see what that graph looks like. Okay, equation 2, we have 2x plus 5 halves y is equal to a negative 3. Again, we are solving for y, so we're going to subtract over that 2x. And then to move this over, I can multiply both sides by 2/5. Notice multiplying by 2/5 would eliminate that 5 halves. Okay, so we're going to multiply both sides by 2/5. So we would have 2/5 times negative 2x minus 3. We'll put this in y2, this one in y1. If we see them intersect, we have one solution. No intersection, no solution. If they're really the same graph, one is on top of the other, then we have infinite solutions. Okay, so let's look at our graph. We have negative 12x minus 18 over 15. And notice I didn't simplify, I just left as is. Okay, we have 2/5, negative 2x minus 3. Again, we didn't simplify, we just left as is. We're going to hit zoom. We're going to hit 6 for zoom standard. And what did we notice? They're an equation on top of another, so we know we have infinite solutions. Now, in the part 1, we learned that if we want to look at solutions, solutions are an ordered pair xy. Since this is infinite solution, we still need an ordered pair xy. How are we going to get an ordered pair? It's not just one solution, it's many solutions. An infinite number of these are solutions to this system. Okay, so what we could do is we could look at either of these equations. Let's pick this one for example. This would be 2/5 times negative 2, which is a negative 4/5 x. We would have 2/5 times negative 3. That's going to be a negative 6/5. And what we have is a way to find y by plugging in certain x's. So we're going to go ahead and plug in certain x's to get out y, and y can be found by plugging into this equation. And this is how we list infinite solutions. This is our final answer. Okay, looking at these three systems, we can use substitution, elimination, or by graph. It's up to us. How do I know which method to use? Well, graphical methods, you probably want to choose that last. What happens if x turns out to be, say, 1/7 and y turns out to be, say, 3/7? Graphically, you're not going to get that 1/7, 3/7. You'll get a decimal, have to turn into a fraction, and that's a lot of work. So we're going to try to use graphical methods as our kind of last resort. Substitution method, we're going to use the substitution method when we can easily solve for one of the variables. As long as you can solve for one of the variables and plug into another, substitution is going to be your easiest choice. So looking at these, no way is it going to be easy to solve for either x or for y. Same thing here. No way to solve for x easily or y easily. In these two examples, we're going to end up with a lot of fractions that we have to do by hand. This one is we can easily solve for x. X is equal to 7 minus y. Or we can easily solve for y. Y is equal to 7 minus x. It doesn't matter which variable we solve for, but we're able to easily solve for one of the variables. So substitution is going to be easy for this one. Okay, substitution. Since graphical is our last resort or our last choice, these are going to be elimination. These two are going to be elimination. You can easily eliminate x by multiplying this by -7. That would give us a -14 plus 14, and x would be eliminated. Here we could multiply, let's say, this one by 2. If we multiplied this by 2, that would give us a 50x. But remember, you multiply everything by 2. This one we could multiply by 5. We would, again, multiply everything by 5, but we would end up with a -50x. When I add these two together, I can eliminate x. You could also work on eliminating y. It doesn't matter which one.